Hello, welcome. Algebra 1, lesson 2.8. So this is module 2, page 8. All right, so we have these equations that we looked at in 2.7 that we're going to go over again. We're going to go over slope intercept and point slope. Those are the main ones we're going to look at, but also we're going to see a little bit of some of these constant functions here, the horizontal line and the vertical line. All right, so slope intercept form, we used it last time to identify what the slope was, what the y-intercept was, but today what we're going to do is we're going to build equations with this. So if you're given a point that is an y-intercept and you're given the slope, you can easily build this equation. So here we have some practice. What is the equation of a line that passes through point 0, -5 and has a slope of 7/3? Well, here we can easily see that this is the y-intercept because it has an x value of 0. Any point on a line that has an x value of 0 is a y-intercept. That means it's going to be on the y-axis. So it means our b is -5, right? And it tells us that our slope is 7/3. So all we have to do is just plug this in and get our equation. So we keep y, m is 7/3, leave the x equals, sorry, not equals, plus b. Oh, well, look, our plus is actually a negative. So instead of saying plus a negative, what we should do is write -5. And that's our equation in slope-intercept form. Building slope-intercept form equations is very simple. It's just plug in the numbers. All right, now we have some point slope forms. Oh, you know what? Going back here, I noticed something right as I was changing the page. Let's see if I can get back to it. It says right here, point slope form. I want to make sure on your notes that this is not point slope form. This is slope intercept form. It's slope intercept form, y equals mx plus b. That's slope intercept form. So that was an error I had in my notes. Make sure your notes are correct and written correctly. It is slope intercept, that's y equals mx plus b. Now, point slope form. Point slope form is a little bit more complicated. It looks scary, it looks daunting, but it's actually pretty easy. So here we have y minus y1 equals m times x minus x1. Now remember, the x and the y are going to stay exactly where they are. And so what we're looking to find is three numbers. We're looking for a y1 and x1. Let me actually, I'm going to want to rewrite that. We're looking for a y1, we're looking for an x1, and we're looking for an m. So we're looking for three numbers. Now, we're given a point right here. So you already know two of the numbers that you're going to plug in without doing any work. So we can easily go ahead and plug in. We see that since this is an ordered pair, this is our x value and this is our y value. So we can just call this x1 and y1, and we know we're able to just plug those in. Well, our example problem here, what is the equation for a line passing through point x1 or 1 minus -2 or 1 comma -2 with a slope of -3/5? Well, we know that slope right there is what plugs in for m. So we have all three numbers and we just need to plug it in. So y stays exactly the same minus, what did we get for y1? It's a -2. Well, we don't subtract a negative, so that's going to change to a +2 equals m is -3/5. X stays exactly like it was. It's not one of the ones we're looking for anything for. And then x1 is just 1. And so this is your equation that you built here, and it's in point slope form. Now, if you need to get it into slope intercept form, which is where y is all the way by itself, all you have to do is you're going to the 2 is going to switch sides, and you're going to distribute this and then combine like terms. So you're just going to solve for y, in other words. And that goes back to, we covered that at the end of last lesson, 2.7. If you want to go back and watch that again, how to solve for y. But since it's not asking me for that in this equation, I'm not going to do it. Linear equation, point slope form. Now, it has, what is the equation for a line that passes through points 1, 2, and -3, 5? This time we're not given a slope like we were last time, but we have the tools we need in order to figure out the slope. If we're given 2 points, we can figure out what the slope is, because remember, the slope equation is change in y over change in x. And this is the same thing as if you just subtract the two numbers, y1 minus y2 over x1 minus x2. Okay, so what we're going to do is plug these in to find our slope using that equation there. But first I need to identify what's going to be my point 1 and what's going to be my point 2. So I usually identify the first number that's given to me as 0.1 and the second one as 0.2. So if you look at this, go over here, I identified it as 0.1. So my x1 is 1, my y1 is 2. This second point I identified as 0.2. So my x2 is -3 and my y2 is +5. Plug that into this formula that we already went over, and you're going to get a slope of -3/4. So I have all three pieces of information I need to write my equation, because remember, y stays how it is. I need to fill in a number for y1, I need to fill in a number for m, and I need to fill in a number for x1. I have all of that information right here. So let's write the equation. Y minus y1 is 2 equals m, which is -3/4, times x minus x1, which is 1. And that is your equation that passes through these 2 points. It's written here for you as well. All right, so now I want you to go ahead and pause the video, work on completing this on your own, and then come back and we'll go over it. All right, welcome back. We have here, we need to write an equation that contains these 2 points. So we need to start by finding the slope. And remember, slope is going to be y1 minus y2. It can go the other way as well, y2 minus y1. That's fine, as long as y1 is over x1. That's the important part. And y2 is over x2. It's an ordered pair, so they need to stay in order. They need to stay paired up. You have to have the x and the y together. Here it's horizontally paired. Here it's vertically paired, okay? So in order to find my slope of question 1, I'm going to put 0.1, 0.2. So m equals, I'm going to start with my first one. I'm going to put the y on top and the x on bottom, put a subtraction sign behind it. Now my second point, the y goes on top, that's +2. The x goes on the bottom, that's -2. Well, I can't subtract a negative, so I'm going to change that to a positive. So 4 minus 2 is 2. 2 plus 2 is 4. So my slope equals 1/2. Okay, well, having that information, I can now write my equation. And remember, my formula is y minus y1 equals m times x minus x1. Okay, so I'm going to write it here. Y minus, well, what's my y1? I have 0.1 here. So this is x1 and this is y1. Y minus 4 equals, m is 1/2. 1/2 x minus x1 is 2. And there you go. I was not asked to put it in slope-intercept form, so I'm just going to leave it here in point slope form. All right, so now I'm asked to write an equation for a line that contains the point 3, -2 and has a slope of 0. Remember, if something has a slope of 0, it is a horizontal line. So that means it's one of our ones that's a constant. Let's think of this on a coordinate plane. Is it going to be y equals a number or x equals a number? Which one is it? If you don't remember, we can look and find out. Well, in this case, what stays the same? Is it the y value or the x value? If we plug in 1, we're going to get whatever this is. Let's just say it's 1, 2, 3, 4, 5. Okay, well, what if we plug in 5, right? Well, it's still 5. What if we plug in 100? It's still 5. So y is always 5. So in this case, we know that it's going to be this equation and not this one. The y equals is the horizontal line. The x equals is the vertical line. Remember, and a horizontal line has a slope of 0. A vertical line has a slope that is undefined. Okay, so in this case, since it's y equals a number, I don't have to use my point slope formula. I can simply write y equals, and then take the y value, -2. And that's my answer. So let me clear some workspace for us here. Now we have 2 points here and no slope. So let's look at this. I'm going to name it 0.1 and 0.2. So -2 over 3 minus 7 over 3. Okay, same sign. I'm going to combine 7, 8, 9. All right, so that's a 9. And then I need to make sure the sign comes over. 3 minus 3 is 0. Whoa, that's not going to work. Any fraction where 0 is in the denominator is illegal. That's undefined. Oh, undefined. I know that. I just talked about an undefined slope. What has an undefined slope? A horizontal line. And what is a horizontal line? It's x equals something. And we can see that right here because our x values are exactly the same. So x equals 3. Okay. All right, moving on. We now have a line that goes through this point and has a slope of -3. We already have all of our values, x1, y1, and m. So I'm just going to jump right into writing the equation. Y minus a -5 turns into y plus 5 equals m is -3 times x minus x1 is 2. And we're done. All right, so here we have, oh, I was hoping this was going to be a y-intercept so we could use the slope-intercept form, but this is an x-intercept since the y value is 0. So we still need to use the point slope formula. All right, so 0.1 and 0.2. 0.1, I'm going to put -8 over 1, subtract. 0 is the y over 9. -8 minus 0 is -8. And 1 minus 9, they're different signs, so I'm going to find their difference. 9 minus 1 is 8. The bigger value of 9 gets the answer. So -8 over -8, well, that's easy. That's a slope of 1. Hey, I know what that line is. Anything with a slope of 1 is y equals x. There we go. We're done. Now, we need to write our last problem here. Contains the point -4, 1 and has an undefined slope. Undefined slope, I know, is a vertical line. Vertical lines are x equals, and then I just need the x value, x equals -4. And I'm done. Hopefully you got all the correct answers as well. If not, you can go back and rewatch this. Do them again. Now we have a real world example here. Let's imagine you're riding in it's called a taxi cab here. That's, what we used to take before there were Ubers. Imagine you're riding in a taxi cab and the cab charges an initial fee once you get in the car. Oh my gracious. So there's a major fee, even if you just sit down and then get out again, you're getting charged, right? But then also you get charged per every mile that's driven. And you notice after you've gone 3 miles, you have a charge of $8. And then after 9 miles, you have a charge of $17. So you need to write a function C to represent the cost of the taxi cab after driving the certain number of miles. So the first step in this problem is to determine which of the given information represents the dependent and independent variables. All right, so the first step for this problem is determining which of the given information represents the independent and dependent variables. So we have independent variable. That's the one that's not gonna depend on anything. It's gonna be the input value. So that's how many miles is driven. That determines what our end cost is gonna be. And remember, we have mile 3 and mile 9 that we looked at. And then the dependent variable, the cost of our ride in this taxi, depends on how many miles are driven. So the cost, depending on 3 miles, if we've gone 3 miles, is 8, and the cost, if we've gone 9 miles, is 17. So now we're going to find the rate of change, which, remember, is the slope for a linear function. So the difference in the y values, or the dependent values, 17 and 8, is 9. And the difference in the x values, or the independent values, is going to be 6, because we can write these as an ordered pair. Our independent value here is 3. Our dependent value is 8. That's 0.1. Our independent value is 9. Our dependent value is 7. So you can see our ordered pairs there. That's how we're able to find this slope. Now, our slope is 1.5. We can go ahead and write an equation. I've filled in the information here for my y1 value and my x1 value and my slope. Then I've rearranged it all. I've distributed the 1.5. I've rearranged it so that I have it in slope intercept form. Y equals mx plus b. Okay, so we're going to take that information and we're going to utilize it to answer the following questions. What is the initial cost for the taxi before driving any miles? Okay, I have here, let's move this so you can see it. If you drive 0 miles before driving any miles, that's 0 miles. If you plug that in, what are you going to end up paying? Well, you're going to end up paying the 3.5, right? So our answer is 3.5, $3.50. What is the cost per mile for the taxi? Okay, well, that means what is the cost per mile? What is the coefficient of the variable? So it's $1.50. How much will the fare be if you drive 12 miles? Well, you're going to plug this in, 1.5 times 12 plus 3.5. Okay, then all you have to do is get out your calculator, plug it in, 1.5 times 12 plus 3.5. This is 21.5. So it's going to, if we go 12 miles, it's going to cost us $21.50. If you pay 14 miles, how many miles do you drive? Well, we're going to plug that into the cost. So we're going to have 14 equals 1.5x plus 3.5 and solve. So once you've done all that math, that means you've driven 7 miles. What is the domain or the input for this situation? Okay, well, how many miles is possible for you to drive? Are there any restrictions on how far you can drive? Well, you could go any number of miles that's positive, right? Can you go negative miles? No, I don't think you could go -3, -2, anything like that, but you could go 1.5, whatever. So remember, our domain is going to be 0, 1, 2, 3, etc. So this is not all real numbers, because all real numbers includes the negatives as well. So I hope you remember what number set this is. Our natural numbers are 1, 2, 3, but then after that, we have our natural numbers, our, let's see, natural numbers, counting numbers, real numbers, integers. It is our integers, our whole numbers, okay? So it's going to be the set of whole numbers or all positive numbers. Okay. So that's how you get all of your answers for this equation.